This is tutorial 7 question 7. In this question we are given the information of 7 individuals where we are given the height and the weight, and we are asked to find a model that relates the height when given a weight. Basically we are asked to use this linear model. Weight equals to beta 0 plus beta 1 times the height, and we are asked to find beta 0 and beta 1. To solve this, we have to find the design matrix, where the design matrix X will consist of two columns. The first column is all the values of 1, and the second column will be the values of the height. In this case, we will enter 48, 50, until the last element 73. This is the input of height here in inches, and we are asked to predict Y, where Y is the weight in pounds. The first one of course is 93 as we see in the table, second one is 105, and the last one is 180. Once we have this formula, we can plug x beta equals to y and solve the normal equation. Let's see how we do it. In my solution, I've used MATLAB to solve the problem. MATLAB is not required in this course, but we will show you now how it is done in the real world. This is MATLAB. You can use Python, NumPy to solve the same problem as well. First, let us construct the design matrix. In this case, I call it H, and in the first column is a value of 1, 7 of them, 1, 2, 3, 4, 5, 6, 7 for the 7 element. The first one is 48, 50, and the last one is 73. Let us now see our original table. The first entry is 48, second entry is 50, and the last one is 73. So we have plugged in the values correctly. After that, we are going to save our Y, which is our weight. The first entry is 93, 105, and the last one is 180. Let's see it again. It is 93, 105, and the last one is 180. So we now have initialized the height and the weight as matrices for height and column vector for weight. We then solve for beta. Beta is equals to transpose H transpose times H inverse times H transpose times weight. You might know it as this original equation, A transpose A inverse A transpose Y. Here we are just using a different variable name, but the idea is the same. Beta is calculated in this equation, and we found the beta as this. We now can use this equation of beta to plot the given estimated weight given the input height. I use height from the second entry of, or the second column of H, and let us plot. So this is the answer. This is the green value, which is the estimated weight given the input height. The crosses are the 7 values given to us originally. If we zoom in, we'll see that the green line only approximate the crosses because it doesn't pass through all of them. There are errors between the actual value and the estimated value, and in the second part of the question we are asked to plot this. So let us zoom in. We'll zoom in here. We see the values, and now we use the distance between the crosses and the green line to know what is the error, and we see that These are the errors, and of course we can plot it in a different way where we have the height, we have the difference, the residual error between each of these points. So this is this point, this is this point, this is this point, and so on. Okay, so with that, then we can answer question 7A and 7B. Thank you.